Hello. In this video, I will go through the process of using LiMovie on a video of a drift-through observation of an asteroidal occultation, one in which tracking is not very precise or is purposely allowed to drift. Open up LiMovie, and let's open up an AVI file that I know works well. This is from a drift-through of Viola that was done. So here's our video. Notice first it uses an iota VTI, so we need to go over here and switch to iota and double check that the times are being read properly. Looks okay. Remember, you can adjust this threshold up and down a little bit to make sure that's working well. From experience, I know this occultation occurs after frame 500, so I'm going to step up here a little bit. To frame 500. The target is right there, pretty tough to see. One way you can help yourself out if you're just setting things up is to go over here to the gamma correction and select field, and then type in a new number and hit enter, and it'll brighten the whole field up and I can see the star a little bit better. So let me set that star, set the aperture. I'm going to need to enlarge it for sure because the star is pretty fuzzy. We can double check with our 3D star image like we did yesterday. And that looks pretty good. We have a star right here that we need to contend with, so let's turn on avoid sunlit face and set the direction of that around like this. Now we've avoided that star, and there's our target. Don't forget to turn this off, so we're back to the original video. Now we're going to drift, and this whole thing drifts to the left, so I'm going to select a star up here. Oh, make sure that's turned off. Okay. And well, let's do this. If you turn it on and adjust the radius down a little bit, it recenters it. It makes it a little better. Now we can turn it off. Let's select this guy right here by right-clicking and Object Add. Once again, we have to enlarge the apertures a little bit. The star is a little bit out of focus. We can take a look at the 3D star image to be sure we're enclosing it. That looks pretty good. This is going to be our star used for tracking, so we want to have that drift and we want to link it to the previous star. Right, so we're all set there. Well, let's turn our threshold up a little bit. We used about 80 before. Let's turn that down a little bit. All right. So there's our target, and there's our star used for tracking. I found from experience that in this case we need to leave the tracking on for PSF, otherwise it doesn't seem to track across the field very well. So we're all set. Let's see what we get. Notice everything is tracking toward the left as we expect. The star disappears at around frame 650. And there it goes. Comes back at about frame 750. And there it is. We'll let this go a little bit longer to get a decent look at the light curve. That should be good. Let's stop there. Take a look at the graph. Right. So there's our tracking star, and here's our target star. Nice occultation. Looks like something's going on in the light curve there, but it could be anything. You need to save that as a CSV file for further analysis. All right, I'm going to use this video for another example of what can be done. What if you had no stars whatsoever except the target in a field of view? Happens from time to time. Let's turn off this one right here. Just remove it. We're going to just use our first one. So let's go back and recenter it. So right click and set to position and set it to drift. And let's leave the raise at 6 and the threshold at 80. So now we're in the right position to start the drift. How do we do that? Well, since it's a steady drift to the left, I'm going to set this to drift and set frame 500. So now it knows where this begins, frame 500. Let's go out to about frame 900, give or take, doesn't matter. Recenter the star, right click, set the position, and now set frame 890. What's going to happen now is the star is going to steadily move toward the left, and the aperture is going to move right along with it. So let's go back to where we were. There's frame 500. You notice when I went backwards, it followed it right along. So now this aperture is going to track right along with the star from frame 500 to frame 890. Let's remove our data. We're on drift. Looks like the radius and threshold are good values. And let's start and see what happens. Okay, we're drifting toward the left. Everything seems to be okay. It should disappear at about 650. Notice it jumps around a little bit trying to look for the star. But it is moving toward the left on a regular basis, and there's our star back. We'll go a little bit longer here so we can get a look at the light curve. Okay, let's stop there. And here's our light curve. A little bit noisier, but we still get a decent result that we can use in the analysis software. And don't forget now to save that to a CSV file. If it jumps around a little bit too much for you and you want to kind of set that a little bit lower, you can reduce the threshold down a little bit or increase the radius, and that should prevent the jumping around. Okay, good luck with your observations.